Impulse and momentum. In Newton's second law, his original thinking was not in terms of an object's acceleration. So far we've learned that F net equals ma, but there's a little more to it. So Newton, he stated that the rate of change of momentum of an object is proportional to the net force applied, and the change in momentum and the net force are in the same direction. So our change in momentum is delta. Delta just means the change, P, is equal to the force times the time. And we know that delta P is the change in momentum. It's usually caused by an impact or a collision of objects. So when police are trying to figure out in a car scene how fast, by measuring the skid marks, how fast a car was coming, they're using momentum. So momentum is when we have a collision or even something exploding. The change in momentum, delta P, can also be called impulse, J. So the symbol for impulse is J, or you can just leave it as delta P. The units for impulse are newtons per second. Impulse, or J, depends on two factors: the magnitude of the force exerted on the object and also the length of time for which it acts. So we have this big long formula. We know that momentum is just mv. So if you want the change in momentum, it'll be mvf minus mvi. Another symbol for delta P is J, and we also know it's equal to force times time. So we've kind of learned all these formulas. So J, delta P, force times time, or just simply mvf minus mvi all mean the same thing. The last thing is if we graph it. If you graph force versus time, well, the area under the graph will actually give us our impulse. So impulse is that change in momentum. Let's try an example now. What velocity will a 40-kilogram child sitting on a 40-kilogram wagon acquire if pushed from rest by a force of 75 newtons for 2 seconds? So first thing we do, like we always do, is write down our given information. We know mass of the child is 40 kilograms. We know mass of the wagon is equal to 40 kilograms. And because the child's actually sitting on the wagon, what we want is the total mass. So we just simply go 40 plus 40 will give me 80 kilograms. So the child and the wagon are acting like a unit. All right. So what else do we know? We know that the force is 75 newtons. And the time is 2 seconds. We are looking for the final velocity, so VF. Well, we know that impulse, or delta P, is equal to force times time, which I have both those things, and it's also equal to the change in momentum, which is mvf minus mvi. Now I'm assuming that we're just moving forward, so I'm just going to put the direction forward on here. So if I know F, T, M, and VI, I can actually solve for VF. Right off the bat, I know VI because it's starting from rest. Child sitting on it requires from rest, so I know VI is equal to 0, so that disappears. So now I'm left with Ft is equal to mvf. To get vf all alone, I divide both sides by m. And I have vf is equal to ft divided by m. I plug in what I know. So the force is 75. The time was 2. The mass was 80. Just going to move this a little higher. And I end up with 1.9 meters per second forward.